The Siberian Traps volcanic eruptions were one of the most destructive geological events in Earth's history. Around 252 million years ago, massive volcanic activity occurred in what is now northern Russia. Instead of a single eruption, this event involved repeated outpourings of lava over a very long period of time. Molten rock flooded the surface and spread across millions of square kilometers, forming thick layers of basalt that permanently reshaped the land. These lava flows were so extensive that they altered Earth's surface on a continental scale. The greatest damage, however, came from what the eruptions released into the atmosphere. As the magma rose through the crust, it passed through layers of rock rich in carbon and other chemicals. This process released enormous amounts of carbon dioxide and methane into the air. These gases trapped heat and caused rapid global warming. Once temperatures rose sharply, the climate became unstable across the entire planet. Volcanic sulfur gases also produced acid rain, which damaged land ecosystems and altered soil chemistry. Warmer waters held less oxygen, leading to widespread oxygen loss in the seas. At the same time, increased carbon dioxide caused ocean acidification, which weakened shells and skeletons of marine organisms. These combined stresses led to the Permian-Triassic mass extinction, the most severe extinction event ever recorded. Over 90% of marine species and most large land animals disappeared. The eruptions also permanently altered Earth's atmosphere and carbon cycle. Climate systems took millions of years to recover, and ecosystems rebuilt slowly. About 66 million years ago, a massive asteroid struck Earth near what is now the Yucatan Peninsula in Mexico. The impact created the Chicxulub crater, which measures more than 150 kilometers across. This collision released an amount of energy far greater than any volcanic eruption or nuclear weapon in human history. In seconds, rocks were vaporized, shockwaves traveled through the planet, and debris was thrown high into the atmosphere. The most important changes happened after the impact. Dust, ash, and tiny particles spread around the globe and blocked sunlight for months or even years. With sunlight reduced, global temperatures dropped sharply. Plants struggled to photosynthesize, which caused food chains on land and in the oceans to collapse. The impact also released large amounts of sulfur gases from the rocks it struck. These gases formed aerosols that increased cooling and caused acid rain. Oceans became more acidic, making survival difficult for any marine organisms. Together, these changes triggered the extinction of about 75% of all species on Earth, including all non-bird dinosaurs. This event ended the age of dinosaurs and allowed mammals to expand into newly available ecological roles. Around 74,000 years ago, the Toba supervolcano in present-day Indonesia produced one of the largest volcanic eruptions known in recent geological history. The eruption expelled thousands of cubic kilometers of ash, gas, and volcanic material into the atmosphere. Ash from this event spread across large parts of Asia, covering land surfaces and altering ecosystems far from the eruption site. The most significant planetary change came from the volcanic gases released into the upper atmosphere. Sulfur-rich particles reflected sunlight back into space, reducing the amount of heat reaching Earth's surface. This caused a period of global cooling that lasted for several years. Some regions experienced colder and drier conditions, which disrupted vegetation and animal populations. The eruption also caused a major physical transformation of the landscape. When the magma chamber beneath the volcano emptied, the ground above collapsed inward. Over time, water filled this depression, creating Lake Toba, which remains one of the largest volcanic lakes on Earth today. Although earlier theories suggested the eruption nearly wiped out humans, more recent research indicates that the effects varied by region. The end of the last ice age marked one of the most dramatic climate transitions in Earth's recent history. As global temperatures rose, massive ice sheets that covered large parts of North America and Eurasia began to melt. This melting released enormous volumes of fresh water into the oceans in short periods of time, known as meltwater pulses. One of the largest pulses caused sea levels to rise by more than 15 meters within just a few centuries. This rapid rise in sea level permanently reshaped Earth's coastlines. Vast areas of land that were once dry became submerged, creating new seas and changing the shape of continents. Shallow coastal plains disappeared, and ocean boundaries moved inland. These changes altered ocean circulation patterns, especially in the Atlantic, where the influx of freshwater disrupted major current systems that help regulate global climate. As the heavy ice sheets melted, the land beneath them slowly rebounded upward in a process called isostatic adjustment. This uplift changed river paths, drainage systems, and regional landscapes. At the same time, warmer temperatures shifted climate zones toward the poles, transforming ecosystems worldwide. The now more stable climate allowed forests to expand, sea levels to stabilize, and complex ecosystems to develop. The Black Sea flood refers to a major geological and environmental transformation that occurred around 5600 BC. Before this event, the Black Sea basin existed as a much smaller freshwater lake. As the last ice age ended, global temperatures rose and massive ice sheets melted. Eventually, the rising Mediterranean Sea reached a critical point where it overtopped the land barrier. When this happened, saltwater rushed into the lower Black Sea basin with great force. The inflow of water was rapid and powerful, flooding surrounding land and raising the water level by many meters. Areas that were once dry land or shallow freshwater shores were quickly submerged. This flood completely changed the nature of the Black Sea. A freshwater lake was transformed into a deep saltwater sea. The chemical composition of the water shifted dramatically, leading to changes in marine life. Species adapted to freshwater conditions disappeared and were replaced by organisms suited for saltwater environments. The expansion of the Black Sea also reshaped coastlines and affected regional climate conditions. A larger body of water influenced humidity levels, wind patterns, and seasonal weather in surrounding regions. The eruption of the Thera volcano occurred around 1600 BC. The volcano erupted violently, releasing enormous amounts of ash, rock, and volcanic gases into the atmosphere. The force of the eruption was so great that it destroyed much of the central part of the island. As magma was expelled from beneath the volcano, the ground above collapsed inward. This collapse formed a large volcanic caldera, dramatically altering the shape of the island and the surrounding seafloor. The eruption was accompanied by strong earthquakes that fractured land across the region. Soon after, massive waves moved outward across the Aegean Sea. These tsunamis struck nearby coastlines, eroding land, destroying coastal features, and depositing marine sediments far inland. Volcanic ash from the eruption spread across large parts of the eastern Mediterranean. Thick layers of ash settled on land and in the sea, changing soil composition and affecting plant growth. The ash that entered the ocean altered water chemistry and reduced sunlight penetration, affecting marine ecosystems and productivity. Sulfur-rich gases released into the upper atmosphere reflected sunlight away from Earth's surface. This led to regional cooling that may have lasted months or years. Climate records suggest disruptions to weather patterns following the eruption. The physical collapse of the volcano and redistribution of volcanic material reshaped ocean currents and underwater landscapes. The eruption of Mount Vesuvius in 79 was a powerful volcanic event that dramatically reshaped the surrounding environment. Located near the Bay of Naples, Vesuvius erupted with explosive force, sending volcanic gases high into the atmosphere. Winds carried this material across large areas, spreading ash over land and sea. As ash and pumice fell back to the ground, they covered fields, forests, and settlements with thick deposits. This sudden accumulation altered the landscape by burying surface features and changing drainage patterns. Rivers and streams became blocked or redirected by volcanic debris. The heavy ash load caused roofs to collapse and triggered landscapes on nearby slopes. Lava flows from the eruption destroyed vegetation, and entire towns were buried, preserving buildings and streets beneath hardened ash and rock. Sulfur dioxide and other gases released during the eruption reacted in the atmosphere to form fine particles. These particles reflected sunlight, causing temporary cooling in the region. Changes in wind and rainfall patterns followed, affecting agriculture and ecosystems. Volcanic material that settled into nearby waters altered marine environments by reducing light penetration and changing water chemistry. Over time, Erosion acted on the new volcanic soils, influencing vegetation growth and land stability. The Little Ice Age was a prolonged period of cooler global temperatures that lasted from about 1300 to 1850. During this period, average temperatures dropped in many parts of the world, leading to significant physical changes across the planet. This cooling did not occur all at once, but came in waves that affected climate systems for several centuries. One major factor behind the cooling was frequent volcanic activity. Large eruptions released ash and sulfur-rich gases high into the atmosphere. These particles reflected sunlight back into space, reducing the amount of heat reaching Earth's surface. Because eruptions occurred repeatedly, cooling effects overlapped and helped sustain lower temperatures over long periods. As temperatures dropped, glaciers expanded in mountainous regions across Europe, North America, and Asia. Ice advanced into valleys that had previously been ice-free, carving new landforms. The weight of expanding ice reshaped terrain and altered river systems fed by glacial meltwater. Cooler conditions also affected oceans and atmosphere circulation. Sea ice extended farther from polar regions, influencing how heat moved around the planet. Changes in wind patterns led to more unpredictable weather, including harsher winters and cooler summers in many regions. The Lisbon Earthquake of 1755 was one of the most powerful and destructive earthquakes in recorded history. On the morning of November 1st, the ground shook violently across Lisbon and surrounding areas in Portugal. Buildings, streets, and bridges collapsed, and fissures opened in the ground that were several meters wide. Large sections of land shifted or sank, permanently changing the urban landscape. The earthquake was felt far beyond Portugal, reaching Spain, Morocco, and even parts of North Africa and Europe. Soon after the shaking stopped, the sea withdrew from the shore, exposing the seafloor. This was followed by a series of tsunami waves that surged inland with immense force. These waves reshaped the coastline, eroded river mouths, and carried marine sediments far onto the land. Beaches were destroyed, and new channels formed in previously stable areas. Fires ignited when candles fell from homes and churches, spreading rapidly through the city. The heat from these fires melted materials, leaving burned landscapes. The combination of ground rupture, tsunami, and fire destroyed most of Lisbon's infrastructure and reshaped the surrounding environment. Watercourses and river paths were permanently altered by debris and sediment, and coastal plains were submerged or modified by the tsunami. The earthquake and its aftereffects also triggered long-term changes in sediment layers that are still visible today. The eruption of Mount Tambora in 1815 was the largest volcanic eruption in recorded history and had profound effects on the planet's surface and atmosphere. Mount Tambora, located on the island of Sumbawa in Indonesia, exploded with immense force in early April. Large amounts of volcanic material were ejected into the atmosphere. The mountain's summit collapsed inward as magma emptied from beneath it, forming a massive caldera that permanently reshaped the land. The eruption blanketed surrounding landscapes with thick layers of ash and pumice. Rivers were blocked, creating new lakes and altering drainage patterns. Forests were buried, and fertile soil was destroyed. Far from the volcano, volcanic ash and sulfur-rich gases spread into the upper atmosphere. These aerosols reflected sunlight, cooling Earth's surface. The following year, 1816, became known as the year without a summer because of lower temperatures across Europe, Asia, and North America. This cooling disrupted precipitation and altered wind patterns, affecting weather systems worldwide. Ice cores from Greenland and Antarctica contain layers of ash from Tambora, showing the eruption's reach and its impact on global climate. Valleys were filled with volcanic debris, and new layers of rock fused to older formations. Floating pumice drifted across seas for months, reaching distant coasts and temporarily altering marine habitats. The eruption changed both the local and global environment. It reshaped landforms, altered river and ocean patterns, and affected climate systems for months and years. The eruption of Krakatoa in 1883 was one of the most violent volcanic events in modern history and reshaped both land and sea in the surrounding region. Krakatoa is located in the Sunda Strait near Indonesia. Explosions destroyed a large portion of the island and caused its central part to collide into the sea. This collapse created a caldera and permanently changed the local seafloor. The force of the explosion generated massive shockwaves that traveled around the world and produced one of the loudest sounds in recorded history. The collapse of the island displaced enormous volumes of water, generating tsunamis that struck nearby coast. These waves reached tens of meters in height, destroying coastal villages, carrying marine sediments inland, and reshaping beaches and plains. Volcanic ash and gases entered the upper atmosphere and spread across the globe. Fine particles reflected sunlight, causing temporary cooling in the northern hemisphere and disrupting weather patterns for months. Locally, thick layers of ash buried forest, agricultural land, and river valleys. New landforms emerged as debris was redistributed across the region. The event left permanent physical marks on the Earth's surface, from the submerged island and new caldera to coastal modifications and sediment deposits across the strait. The Tunguska Event occurred on June 30th, 1908 in a remote region of Siberia and produced a massive explosion that altered the landscape over an area of more than 2,000 square kilometers. This cause was a small asteroid or comet entering Earth's atmosphere at high speed. The object exploded in the air above the Tunguska River, releasing energy estimated at 3 to 50 megatons of TNT. The explosion created a shockwave that flattened forests in a radical pattern. From the blast center, trees were snapped, stripped of branches, and scorched by heat. Soil was compressed and scorched, leaving lasting changes to the ground surface. No impact crater formed because the object disintegrated before reaching the ground, but the physical evidence of the blast is clear. This event knocked people off their feet hundreds of kilometers away and caused instruments in distant cities to record pressure waves. Local rivers and streams were affected by fallen debris, and the destruction altered the course of small waterways. The sudden clearing of vegetation changed local ecosystems and opened areas for new plant growth. Over time, regeneration created new forest patterns, but the ground bore evidence of compression and charring. The Great Flood of China in 1931 was one of the most extensive and physical transformative flooding events of the 20th century. This disaster occurred when several major rivers, including the Yangtze, Huai, Yellow, and Grand Canal systems, overflowed after months of continuous rainfall and repeated cyclones. The upper reaches of these rivers were swollen from melting snow and ice, which added tremendous volumes of water to already full river channels. Water levels rose far above historical records, and floodwaters spread across vast areas of eastern and central China. The physical impacts of the landscape were dramatic. Entire floodplains were submerged under shallow seas for months. Rivers cut new channels and eroded banks, while thick layers of sediment were deposited across farmland, towns, and villages. Some areas that were previously dry became marshland or shallow lakes. Breaches in levees and natural embankments caused rivers to permanently change course in many locations. Structures, roads, and settlements were washed away or buried under silt and debris, permanently altering human and natural geography. Even after the floodwaters receded, soils remained waterlogged. Watercourses in river deltas were permanently modified, creating new landscapes and changing the direction and volume of flows. The flood also influenced long-term land use, agriculture, and settlement practices, leaving a lasting imprint on the region. The Indian Ocean earthquake and tsunami of December 26, 2004 was a monumental geological event. It began as a massive undersea megathrust earthquake off the northern coast of Sumatra. The Indian plate was forced beneath the Burma microplate along the Sunda megathrust, causing a rupture that extended for about 1,300 kilometers. The sudden movement of rock displaced the seafloor by several meters, physically lifting enormous volumes of water. This displacement created tsunami waves that radiated across the Indian Ocean at high speeds. Near the epicenter, the vertical displacement of the seabed permanently altered the seafloor, raising some sections of land. As the waves reached coastlines, they flattened beaches, eroded river mouths, and carved new channels inland. Coastal plains were swept away, and marine sediments were deposited far from normal tidal zones. In many regions, shorelines were pushed inland by hundreds of meters. Forests and fields were stripped bare, and agricultural lands were contaminated with saltwater. The earthquake and tsunami also redistributed mass on Earth, causing a minor shift in the planet's rotation and slightly altering the length of the day. The Tohoku Earthquake and tsunami on March 11, 2011 was a major geological event that caused lasting physical changes in northeastern Japan. A magnitude 9.0 earthquake occurred off the coast of Honshu along the Japan Trench, where the Pacific Plate is forced beneath the North American Plate. The sudden release of stress caused sections of the seafloor near the epicenter to move horizontally by tens of meters and vertically by several meters. This displacement lifted enormous amounts of water and generated tsunami waves that traveled across the Pacific at high speeds. When the waves reached Japan's coast, they eroded beaches and carved new channels inland. More than 400 kilometers of coastline experienced permanent changes, and some land dropped vertically by up to 0.6 meters, allowing water to penetrate farther inland. Sediments, debris, and saltwater were carried into rivers, plains, and flood zones, permanently altering ground composition and soil chemistry. Agricultural lands were damaged by salt deposits, and forested coastal zones were stripped of vegetation. The earthquake itself shifted parts of northeastern Japan several meters, closer to the North American continent. This redistribution of mass also slightly changed Earth's rotation and adjusted the planet's axis by a very small amount. Thank you very much for watching this video, and if you learned something, make sure to leave a like. Comment down below your thoughts on any of the natural disasters I discussed in this video, and subscribe if you would like to see a part 2 or more videos like this one. Thank you again, and goodbye.